The silver bombers climbed through morning sky over Saipan. Their engines roared with power that Japanese engineers could never match. November 24, 1944, would mark another demonstration of American technological dominance. 110 B-29 Superfortresses rose from Isley Field. Their destination was Tokyo. Lieutenant Colonel Robert K. Morgan pushed the throttles forward on dauntless Dottie. Behind him stretched a formation that represented industrial might Japan could not comprehend. Inside each engine, nacelle sat the secret weapon. Not bombs or bullets, but machinery. Twin General Electric turbochargers spun at incredible speeds. These devices would prove more decisive than any explosive payload. Hot exhaust gases drove turbine wheels exceeding 20,000 revolutions per minute. The spinning turbines powered compressors that forced air into engine intake systems. This compressed air maintained sea-level pressure, even at crushing altitudes where enemy fighters suffocated. The Wright R-3350 engines delivered their full 2,200 horsepower at heights approaching 32,000 feet. Japanese interceptors designed for lower-altitude combat found themselves helpless in thin air. Their engines gasped and wheezed, where American bombers cruised effortlessly. This technological gap spelled doom for Japanese air defenses. American crews breathed normally in pressurized cabins, while enemy pilots struggled with failing oxygen systems. The morning formation represented the first B-29 strike on Tokyo from newly captured Mariana bases. Only 1,500 miles separated these islands from Japan's capital. Unlike the distant China bases used earlier, the Marianas allowed regular missions with safe returns. The strategic implications were staggering. Japanese radar operators detected the approaching threat. Air raid sirens wailed across Yawata 5 months earlier when the first B-29 mission launched from China. 75 superfortresses had taken off that June evening. Only 47 reached their primary target. The mission cost was severe. 7 aircraft lost. 1 shot down over target. Another destroyed after emergency landing. 5 more in operational accidents. 57 airmen died. Yet even this bloody introduction revealed Japanese defenses were inadequate against high-altitude bombers. Imperial Army pilots of the 4th Sentai scrambled their Kawasaki Ki-45 Toryu fighters. They climbed desperately toward bombers flying between 8,000 and 21,000 feet. Even at these modest altitudes, dictated by fuel constraints on the long China mission, Japanese interceptors struggled terribly. Their Nakajima HA-25 engines lacked effective turbocharging. Each engine produced 1,088 horsepower at sea level. Above 20,000 feet, power output dropped to perhaps 60%. The mathematics of interception had turned against Japan. Warrant Officer Sadamitsu Kimura managed to close on one B-29. The aircraft carried 12 crew members aboard Limba Dragon. His attacks succeeded. The superfortress went down in flames with no survivors. But this lone victory came at terrible cost. Kimura expended nearly all ammunition. His engine overheated dangerously at altitude. He barely returned to base. Around him, other Japanese pilots fired desperately at silver bombers. Most attacks failed to inflict meaningful damage. The B-29's defensive armament responded with devastating accuracy. Advanced fire control systems coordinated multiple turret positions. Japanese fighters found themselves flying through concentrated barrages few could survive. Captain Teruhiko Kobayashi led the Imperial Army's 244th Sentai. He documented growing frustration in unit reports. American bombers operated at altitudes where Japanese fighters barely maintained level flight. Maneuvering for combat became nearly impossible. B-29 speed at altitude matched what Japanese interceptors could achieve in thin air above 25,000 feet, approximately 350 miles per hour. Reaching bombing altitude consumed excessive fighter fuel. Ammunition capacity was reduced. Engines ran so hot that catastrophic failure threatened constantly. The secret lay in technology Japan had explored but never successfully implemented. General Electric's turbocharger represented masterful engineering. Each B-29 engine mounted two devices using exhaust energy normally lost to atmosphere. Q. Hot gases spun turbine wheels that drove centrifugal compressors. These compressors forced air into intake manifolds at pressures equivalent to sea level, even at 30,000 feet altitude. The principle was elegant in its simplicity. Waste energy performed useful work. Each turbocharger installation added approximately 150 pounds per engine, but delivered performance equivalent to doubling engine displacement. Without turbochargers, the B-29 would have been merely another heavy bomber. Vulnerable to interception, unable to utilize altitude as defensive advantage. Japan had experimented with turbocharging as early as 1941. Nakajima Aircraft Company engineers examined captured technical documents. They obtained sample units through circuitous routes before America entered the war. Japanese engineers recognized the military advantage such technology provided. Despite 3 years of development, Japan never produced operational turbocharged fighters in meaningful numbers. The reasons revealed an industrial chasm between the two nations. Turbochargers demanded metallurgy beyond Japanese capabilities. Turbine wheels operated in exhaust temperatures exceeding 1,500 degrees Fahrenheit. Spinning velocities created centrifugal stresses, equivalent to thousands of pounds per square inch. Any metal imperfection caused catastrophic turbine failure. American manufacturers possessed metallurgical expertise that Japanese industry could not match. Precision forging equipment. Quality control systems, the capacity to produce reliable turbines consistently. Japanese industry, stretched thin by wartime demands, struggled to meet these standards. Lieutenant Fumio Niwa served as an engineering officer evaluating captured B-29 components. His findings survived in Japanese archives. Examining a turbocharger removed from a crashed B-29 in China revealed American manufacturing precision. Turbine blades were machined to tolerances measured in thousandths of an inch, balanced so perfectly that units spun at maximum speed without vibration. High-temperature alloys used in turbine construction exceeded anything Japanese industry produced. Even bearings designed for extreme heat, while maintaining precise alignment, represented manufacturing capabilities Japan did not possess. More devastating was the systematic nature of American production. General Electric's Schenectady plant manufactured thousands monthly. Each unit met exacting specifications. Production lines incorporated automated testing equipment. Performance verification occurred before installation. Defective components were identified and rejected. Japanese attempts at turbocharger production yielded perhaps dozens monthly. Reliability remained so poor, most failed after few operational hours. By August 1944, Japanese intelligence compiled disturbing reports about American bomber capabilities. Interrogation of captured B-29 crewmen provided alarming insights. Wreckage analysis confirmed technical superiority. Pilot observations painted a picture that shocked military leaders. The B-29 was not simply a large bomber. It represented a flying weapon system incorporating innovations Japan could not match. Colonel Takashiro Hattori served as operations officer at Imperial General Headquarters. His diary entries from that month revealed growing concern. American bombers operated with impunity at altitudes Japanese fighters could not effectively reach. The few interceptors managing engagement reported disturbing results. Even when scoring hits, B-29 construction absorbed damage that would destroy Japanese aircraft. Most alarming was realization that these raids represented only the beginning. American production capabilities suggested thousands of B-29s would eventually attack Japan, each one beyond effective defensive reach. The mathematics had turned catastrophically against Japanese defenses. A fighter climbing from ground level to 30,000 feet consumed perhaps 30 minutes. One-third of fuel load was burned in the climb. At altitude, fighter performance degraded dramatically. Guns remained deadly at close range, but required pilots to approach within few hundred feet of targets. This maneuver became nearly impossible due to reduced aircraft performance and B-29 defensive systems. Even successful interceptions often cost irreplaceable experienced pilots. Damaged or fuel-depleted fighters crashed attempting returns from extreme altitude. Major Makoto Ogawa eventually claimed 7 B-29 kills. He became one of Japan's most successful Superfortress hunters. His descriptions revealed overwhelming disadvantages Japanese pilots faced. American bombers flew in a realm where Japanese aircraft barely functioned. Pressurized cabins provided heated compartments for bomber crews. Japanese pilots endured temperatures 40 degrees below zero at high altitude. Their fingers went numb despite electrically heated flight suits that rarely worked properly. Oxygen systems frequently malfunctioned. Pilots became hypoxic and disoriented. Gun barrels froze solid. Ammunition belts jammed in extreme cold. Engines ran so rough that pilots constantly feared flameouts. Japanese aircraft designers desperately sought solutions. The Nakajima Ki-87 was developed specifically as a high-altitude B-29 interceptor. It incorporated a turbocharged Nakajima Hei-219 engine. Performance specifications looked impressive on paper. Service ceiling above 40,000 feet. Heavy armament of 30 mm and 20 mm cannon. Speed sufficient to overtake B-29 formations. Only one prototype flew before war's end in April 1945. Severe problems emerged immediately. The turbocharger, cobbled together from inadequate materials, failed repeatedly. Even when functioning, it delivered inconsistent performance. The project died from lack of industrial capacity to produce reliable turbochargers. The Tachikawa Ki-94 represented another proposed high-altitude interceptor. Development never progressed beyond mock-up stage. The Mitsubishi J-8M was a rocket-powered interceptor based on the German Me-163 Comet. Rocket propulsion offered high-altitude capability without turbochargers, but dangerous fuel and extremely short endurance made it impractical for defending against B-29 raids. Japan's finest aeronautical engineers understood requirements. They lacked the industrial foundation to produce solutions. American B-29 operations expanded relentlessly through late 1944. The 21st Bomber Command began flying missions from Mariana bases. Saipan, Tinian, and Guam lay only 1,500 miles from Tokyo, well within B-29 operational range. Morgan's mission on November 24th sent 111 Superfortresses against the Musashino aircraft engine plant in Tokyo. Weather and jet stream winds limited bombing results. The psychological impact on Japan proved profound. American bombers now struck the homeland almost daily. Japanese defenses grew increasingly ineffective. Sergeant Shuichi Suzuki manned anti-aircraft guns stationed near Tokyo. His diary documented growing despair among defenders. Initially, his unit engaged B-29 formations with confidence. Their 75mm guns fired shells to altitudes around 25,000 feet. American bombers often flew higher, beyond gun range. or approached at angles giving gunners insufficient tracking time. More frustrating, even direct hits rarely brought down B-29s. Bomber structure was built with redundant systems. Armor protected critical areas. These aircraft absorbed damage that would have shredded Japanese planes. Suzuki recorded watching crippled B-29s trailing smoke with engines shut down. They continued toward targets, often returned safely to base. Japanese efforts to improve air defenses focused on fighter performance modifications. The Kawasaki Ki-61 Hien was powered by a liquid-cooled He-40 engine. It could reach altitudes around 32,000 feet, higher than most Japanese fighters, but climb rate was insufficient. Engine reliability was so poor, many Ki-61s were grounded awaiting spare parts. The Nakajima Ki-84 Hayate was introduced in 1944. It represented Japan's best mass-produced fighter. The aircraft featured the Nakajima He-45 Homar engine, a complex radial design delivering good performance at altitude when properly maintained. The Homar's intricate construction made it maintenance-intensive. Quality control problems meant many engines failed prematurely. Ki-84 theoretical performance looked impressive. Maximum speed around 400 miles per hour at 20,000 feet. Service ceiling near 35,000 feet. Heavy armament of 20 mm and 30 mm cannon. In practice, few Ki-84s achieved these specifications. Poor quality fuel damaged engines. Crude lubricants broke down at low temperatures. Manufacturing defects caused frequent failures. American pilots who test flew captured Ki-84s after the war praised handling and performance. They noted it matched or exceeded American fighters in some respects. But these captured examples had been selected for exceptional condition, maintained by skilled Japanese mechanics using hoarded high-quality materials. The average operational Ki-84 performed far below design specifications. Even when Japanese fighters reached B-29 operating altitudes, they faced sophisticated defensive armament. Each Superfortress mounted 10 50 caliber machine guns in remote-controlled turrets. A central fire control system allowed gunners to coordinate fire. Multiple turrets concentrated on single targets. The system incorporated computing sites automatically calculating lead and deflection. Hit probability improved significantly. Japanese pilots quickly learned that approaching within effective gun range meant flying through coordinated barrages. Few survived such encounters. The psychological impact on Japanese pilots was devastating. They had been trained to believe in aviation superiority, in invincibility of Bushido spirit over material advantage. Reality of combat against B-29s shattered these illusions. Captain Yasuhiko Kuroe was a veteran fighter pilot with the 302nd Air Group. His letter discovered after the war revealed bitter truth. Fighting B-29s felt like attacking a fortress. Bombers absorbed punishment that would destroy a dozen Japanese aircraft. Their crews were protected by armor and redundant systems. Japanese pilots flew unarmored fighters with vulnerable fuel tanks and minimal protection. December 1944 brought the first major daylight raid against Tokyo. 86 B-29s attacked the Musashino plant. Japanese defenses managed to shoot down or damage several bombers. The cost was terrible. The 244th Sentai, led by Captain Kobayashi, claimed 6 B-29s destroyed through desperate ramming attacks. Multiple irreplaceable pilots were lost in the process. Ramming became increasingly common, as conventional attacks often failed. The tactic was suicidal. Pilots aimed fighters at B-29 wing roots or tail assemblies. They hoped to destroy control surfaces, then attempted to bail out before impact. Few survived these encounters. American crews respected the fanatical courage of Japanese pilots. They were horrified by the waste of lives. Technical Sergeant John McLaughlin served as gunner on City of Los Angeles. He later recounted watching a Japanese fighter deliberately ram the B-29 flying beside his aircraft. The fighter struck the bomber's tail. The entire vertical stabilizer was sheared off. Both aircraft fell from formation in uncontrolled spins. McLaughlin saw no parachutes. He later learned the B-29 crew of 10 men died in the crash. The Japanese pilot's name was never known. One of thousands who died defending their homeland against an enemy they could not defeat. By early 1945, Japanese air defenses neared complete collapse. Fuel shortages grounded many fighters. Experienced pilots had been killed in staggering numbers. Replacements were teenagers with minimal training who stood no chance against veteran B-29 crews. American fighter escorts complicated defense efforts further. P-51 Mustangs flying from Iwo Jima after its capture in March 1945 made defending against B-29 raids even more hopeless. Japanese interceptors climbing slowly to altitude became easy targets. P-51s could outclimb, outrun, and outfight any Japanese fighter. The night of March 9 to 10, 1945 marked the worst disaster in Japanese history. General Curtis LeMay commanded the 21st Bomber Command. He ordered a radical change in tactics. Instead of precision bombing from high altitude, 334 B-29s would attack Tokyo at night, from altitudes around 7,000 feet, carrying incendiary bombs designed to start fires. The decision was controversial. Lower altitude exposed bombers to heavier anti-aircraft fire. LeMay calculated correctly that Japanese night defenses were weak. Lower altitude eliminated turbocharger stress and engine overheating issues. Each B-29 could carry vastly more bombs. Results exceeded LeMay's expectations. In 3 hours, American bombers dropped nearly 2,000 tons of incendiaries on Tokyo's crowded districts. Firestorms developed. Winds sucked oxygen from shelters. Temperatures exceeded 1,800 degrees Fahrenheit. An estimated 100,000 people died. More than either atomic bombing would later kill. 16 square miles of the city burned to ash. Only 14 B-29s were lost. Remarkably low casualties given the raid's intensity. The Tokyo firebombing demonstrated that even without exploiting high-altitude capability, B-29s could devastate Japan. But turbochargers had made the B-29 force possible. Without ability to operate at altitude, bombers would have been limited to operations around 20,000 feet, well within range of Japanese fighters and anti-aircraft guns. Losses would have been unsustainable. The entire strategic concept of bombing Japan from Mariana bases would have been impractical. Missions from China across vast distances required high-altitude efficiency. Daylight precision raids on aircraft factories and oil refineries demanded the protection altitude provided. Even low-level firebombing raids were possible only because American air superiority had been established through earlier high-altitude operations. Those operations destroyed Japanese fighter production. Japanese engineers who examined captured B-29 29 components after the war expressed bitter admiration for American engineering. Turbochargers represented everything Japan's industry lacked: precision manufacturing, advanced materials, rigorous quality control, capacity to produce thousands of complex units monthly. A single B-29 contained 8 turbochargers. American production exceeded 200 B-29s monthly by 1945. That meant 1,600 turbochargers monthly just for new aircraft, plus thousands more for replacements and maintenance. General Electric's factories produced these at rates Japan could not have achieved, even devoting its entire aircraft engine industry solely to turbocharger production. The broader implications were clear to thoughtful Japanese observers. If America could produce turbochargers in such quantities, what else could it produce? The answer was evident in waves of B-29s appearing over Japan almost daily by summer 1945. P-51 escorts that destroyed Japanese fighters with ease, naval forces that blockaded Japan completely, atomic bombs that fell on Hiroshima and Nagasaki. First Lieutenant Toshio Otter served as technical intelligence officer who survived the war. He later wrote that examining captured American aviation technology induced despair among Japanese engineers. Every system demonstrated manufacturing quality and engineering sophistication beyond Japanese capabilities. Turbochargers particularly impressed him because their operation was conceptually simple. Yet execution required precision that Japan's war-damaged industry could no longer achieve. Even had Japan somehow obtained turbocharger designs in 1941, he concluded, it lacked the industrial base to produce them in useful quantities. The human cost of this technological gap was staggering. Japanese pilot training programs, once rigorous and producing superb aviators, had collapsed by 1945. Fuel shortages meant student pilots received perhaps 50 hours of flight training. American pilots received 200 to 300 hours. These inadequately trained pilots flew obsolescent aircraft against opponents who enjoyed every advantage. In July 1945, during a major battle over the inland sea, Japanese fighters attacked a formation of over 100 B-29s. American records show perhaps 2 bombers damaged. Japanese forces lost 23 fighters destroyed, with minimal damage inflicted on bombers. The B-29 campaign ultimately delivered 147,000 tons of bombs on Japanese targets, destroyed 40% of urban industrial areas in 66 cities, killed an estimated 330,000 civilians. Japanese war production, already declining, collapsed completely by summer 1945. Transportation networks were destroyed. Resources could not be moved even where they existed. Workers abandoned factories to flee burning cities. The government lost control of economic planning as industries dispersed into rural areas or ceased operation. Major General Arisue Seizo served as chief of Japanese military intelligence. He admitted after the war that by June 1945 his analysts recognized defeat was inevitable. American air supremacy was absolute. The B-29 campaign had destroyed Japan's ability to wage war. Yet the government, trapped by military codes forbidding surrender, continued fighting until atomic bombs provided justification for capitulation. The atomic bombings of Hiroshima on August 6th and Nagasaki on August 9, 1945, marked the end of World War II. Those atomic bombs were delivered by B-29s, aircraft whose ability to reach targets in Japan and return safely depended fundamentally on turbocharger technology. The Enola Gay flew at 31,000 feet over Hiroshima. It operated at altitude made possible by 8 General Electric turbochargers maintaining engine power in thin air. Even at war's end, with Japanese defenses essentially non-existent, altitude capability provided protection against remaining anti-aircraft fire, allowed crews to escape atomic blast effects. Post-war interviews with Japanese fighter pilots revealed a consistent theme: admiration mixed with frustration. They respected American engineering and recognized that no amount of pilot skill could overcome technological disadvantage. Lieutenant Isamu Sasaki survived the war with 3 B-29 kills, one of the highest tallies achieved. He later reflected that his successes came only when circumstances were perfect. Surprise attacks from above, sun behind him, against isolated bombers separated from formations, against formations flying at altitude with alert crews, Even the best Japanese pilots rarely succeeded. The development of high-altitude aviation capability had been pursued by many nations before World War II. ORTC. Germany developed turbochargers, but never successfully deployed them operationally. They focused instead on mechanical superchargers, which were simpler but less efficient at extreme altitude. Britain relied primarily on sophisticated multi-stage mechanical superchargers. These provided good high-altitude performance without turbocharging complexity. America alone made turbocharging standard equipment on heavy bombers, accepting additional complexity, cost, and maintenance burden in return for unprecedented high-altitude capability. This decision reflected American industrial confidence. Turbochargers required precision manufacturing, regular maintenance by skilled mechanics, steady supply of spare parts. America possessed the infrastructure to support these requirements. Japan did not. Even if Japanese engineers had designed perfect turbochargers in 1941, the nation lacked manufacturing base to produce them in quantity, maintenance organization to keep them functioning, supply system to provide necessary spare parts, and replacement units. The post-war U.S. Strategic Bombing Survey concluded that the B-29 campaign was decisively effective in destroying Japan's capacity to wage war. While survey authors debated whether Japan would have surrendered without atomic bombs or planned invasion, they unanimously agreed on one point. By August 1945, American air supremacy was complete. Japanese defenses were shattered. The B-29's technological advantages, particularly high-altitude capability enabled by turbochargers, made this outcome inevitable once sufficient bombers became available. Japanese records captured after the war revealed the extent to which B-29 raids dominated military planning from late 1944 onward. Imperial General Headquarters devoted enormous resources to air defense. Fighter units were pulled from other theaters. Thousands of anti-aircraft positions were constructed. Tens of thousands of troops were trained for airfield defense. All efforts proved futile against bombers operating beyond effective defensive reach. The final B-29 mission against Japan flew on August 14, 1945. The day before surrender was announced. More than 300 superfortresses attacked targets near Tokyo. They encountered no opposition. Japanese fighters remained on the ground, conserving fuel for the expected American invasion that would never come. B-29 crews returned to their Mariana bases, not yet knowing the war was effectively over. Their missions completed through cumulative destruction of hundreds of raids Japan could not prevent or effectively counter. In decades following the war, aviation historians and aeronautical engineers conducted extensive analyses of B-29 technological advantages. The consensus was clear. Turbocharging provided fundamental capability that made strategic bombing of Japan possible from remote bases. Without this technology, B-29s would have been limited to operations at altitudes around 20,000 feet, well within range of Japanese fighters and anti-aircraft guns. Losses would have been unsustainable. The entire strategic concept of bombing Japan from Mariana bases would have been impractical. The lessons Japanese engineers learned from examining American aviation technology influenced post-war Japanese industrial development. Emphasis on precision manufacturing, quality control, and systematic engineering that characterized American turbocharger production became hallmarks of Japan's post-war economic miracle. Former aviation engineers moved into civilian industries. They brought hard-won understanding of advanced manufacturing techniques. The Boeing B-29 Superfortress flew its last combat mission in 1954 during the Korean War. By then, jet-powered bombers were replacing propeller-driven aircraft. Turbocharging for piston engines had become obsolete. But the B-29's legacy endured. It demonstrated that technological superiority could overcome numerical inferiority. Industrial capacity was as important as individual courage. Air power alone could destroy a nation's ability to wage war. Today, only 2 B-29s remain airworthy, preserved and maintained by dedicated organizations, ensuring future generations can witness these historic aircraft. When these bombers fly at air shows, their Wright R-3350 engines produce that distinctive deep-throated roar. Few spectators realize that hidden within engine nacelles are turbochargers, survivors of technology that helped end history's most destructive war. Those components, spinning at thousands of revolutions per minute as B-29s climb toward altitude, still perform the function they were designed for 8 decades ago, compressing air to maintain engine power in thin atmosphere. The story of Japanese forces facing B-29 Superfortresses ultimately demonstrates how industrial capability and technological development determined modern warfare outcomes. The turbochargers that allowed B-29s to operate at 30,000 feet. The industrial system producing thousands of these complex components. The training programs preparing crews to use them effectively. The supply system keeping them functioning. These were the true weapons of the strategic bombing campaign. The B-29's technological superiority did not make American victory certain from war's beginning. But once American industry mobilized, once B-29 production reached full scale, once Mariana air bases became operational, defeat became inevitable for Japan. No amount of pilot skill could overcome material and technological advantages. No level of sacrifice could match what was embodied in those silver bombers that droned overhead. At altitudes where Japanese fighters gasped for air, when B-29 crews flew at 30,000 feet over Japan, their turbochargers spinning silently within engine nacelles, they carried more than bombs. They carried proof that industrial might had become the decisive factor in modern warfare, that America possessed that might in quantities no enemy could match. Japan never grasped this reality until too late. Once the silver bombers filled the skies over the homeland, operating beyond defensive reach, there was nothing Japan could do to stop them. The technological revolution in aviation had passed Japan by. Those spinning turbochargers, maintaining sea-level power in stratospheric air, represented the difference between victory and defeat, between survival and destruction, between the old world and the new.